Okay, so the recording is now on, and we were talking about industrial control networks. So let me remind you that we need only 2 more classes. That means today and on Friday, we will be having classes, and this week we will finish our course. And we had been talking about industrial control networks. So let me review what we discussed on Monday. On Monday, we talked about the basics of industrial control networks, where we started with uh, the industrial webs, like what we mean by industry 1.0, 2.0, 3.0, and 4.0. Then we have talked about the application domains of ICN. We have either discrete manufacturing, or we can have process control, we can have building automation, we can have utility distribution, transport, and embedded systems. Now, obviously, in discrete manufacturing, we can have a conveyor belt kind of things, and in process control, we have like the steel plants and so on. Building automation includes IoT and other kind of surveillance and security systems. Utility distribution includes power grid. Transport includes many different forms of transport. And finally, the embedded systems, where probably electronic things are integrated into a small system. So in all these domain, we can have the industrial control networks, the application of industrial control networks. Now, let me talk about the information that is passing through the industrial control networks. Well, we have generally 3 types of information. One is control information, the second one is diagnostic information, third one is safety information. Control information is about like the actuators and other things. Diagnostic is about the regular record of temperature and so on. And safety information are like the gas leakage and those kind of events. And then the most important thing that we discussed in our last class was the difference of the industrial control networks with the enterprise networks. By enterprise networks, we mean the networks that we use in our home or in offices. And we have shown that there are many different parameters in which the industrial control networks differ from the conventional networks. We described them in detail in the later slides. Like, for example, the hierarchy is much deep in industrial networks. Then the failure severity or reliability requirement is much higher in the industrial control networks. The third one was delay and delay jitter. We explained both, like the round trip delay as well as the variation of the delay. We want both of them to be as minimum as possible for industrial control networks. And finally, the traffic type. Well, we talked about the packet sizes or data amount. The data amount is generally less, but they can be either periodic or non-periodic, and they require generally timestamps and synchronized clocks. We ended our previous class with a description of the modules that we see in an industrial control network. Generally, we have field devices, and they are at the device level. On top of that, there is a control level, where we have generally programmable logic controllers or PLCs. And above on that, top on that, we have a switch which connects these PLCs, maybe from a field or maybe from different fields. And finally, they go to some human machine interface. To give you a practical view, the same diagram that we have shown earlier is now shown with the help of an exact industrial scenario, where probably we have some oil rigs which are probably like we need to control the set points, the pump speed, the valve, and so on. And they are being controlled with programmable logic controllers. They are going to a switch. So these are the programmable logic controllers that you can see. And this is the switch. And also there might be a wired and wireless network combined. So this is a base station kind of thing, which is connected to a wireless switch, which is connected to some other sensors. All this data that is collected through the switch and the base stations are going to some server, which is the supervisory control and data acquisition, which is called SCADA. And then it is going to some human machine interface, which might be a very big panel of different parameters. So it can have a big display board where we can have different graphs showing up. Now, what we want to discuss today is like how these things are connected and what are their components. Like the industrial networks are generally composing of specialized components which may not be visible in the home or the office networks. For example, we have programmable logic controllers, which is a very specific thing for the industrial control networks. The second thing is the SCADA system, which is supervisory control and data acquisition system. And the third thing is the distributed control system. Now, the distributed control system is something like even a kind of like modification of this, and we can either use DCS or SCADA. Now, generally, they have two different domains of application. The DCS is generally process driven. On the other hand, the SCADA is event driven. That means DCS is good for monitoring regular processes. SCADA is good for probably event triggered or like the safety information handling. SCADA is a bit more general because they are having a large areas and they can handle diversity better. But the reliability is a bit lower in case of SCADA systems. Also, the SCADA systems are probably better in the form of power. Now, let me talk about the levels once again. Like we talked about the levels here. So I go back to the modules. Like these were the modules we described. We have device level, we have control level, we have supervisor level. Now we try to explain them in a much more hierarchical fashion. So you can consider this pyramid as the OSI kind of layers which we had in case of computer networks in an office environment. I hope you remember the OSI layers. Like we had physical layers, we had data link layers, and on top of that, similar to that, we have similar layers in an industrial control network as well. We have L1 layer at the lowest field level, where you can see the valve, the pumps, the actuators, and so on. So there are the sensors, the positioners, actuators, which is at the lowest level of the pyramid, and they can measure different things. Like they can measure temperature, they can measure pressure, they can measure flow, and their data that they produce can be either digital or analog or hybrid. Depending on the type of sensor that we are implementing. Now, there is an L2 level, which is the IO level, which is basically combining such kind of things. Like you can have different sensors, but we can probably combine the data from similar kind of sensors through a common field bus or so. So that is the IO level, which we have as L2 level. Now, the L3 level is the control level, where we have this PLCs. So you can sometimes this L2 level is connected to the L3 level itself. Like the PLCs have also the like the accumulation part, but mostly the L3 level is having either PLCs or DCS, where it generates the control signals. The control signals means like when to open the valve, when to stop the motor, when to take the record of the temperature, and so on, and such kind of things. So these are the things that exist in the L3 level, and they send the signal through L2 to L1. Now, what are the examples? Well, for example, opening or closing of a valve, or starting or stopping of a motor. So these are the PLC things or DCS things which generates these control signals that goes to the actual field level devices through the L2. So these are the three basic levels. Now let us talk about the higher levels, like the HMI and the even higher level, where the management is involved. So in the next level, we are going to talk about the L4 level. This is the L4 level, which is going to connect to these PLCs or DCS. Now this HMI level is the human machine interface level. Well, below this, it is all machine to machine. So here actually the human interacts. Now, in this human machine interface, as I said earlier, we have big panels. So those panels are probably showing the record of temperature, flow, humidity, and other kind of parameters. And you can decide on the basis of that how you are going to change the operation. So in the human machine interface, we also have many kind of engineering tools, like how we are going to have a planned maintenance schedule, how we are going to manage the assets, and also the display that I was talking about, that which displays the process variable values on an operator console. Operator console is a very big panel kind of thing, like in probably a space control mission, probably you see a very big wall of monitors. So that kind of thing. So those displays are generally shown to an operator who takes a closer look at this, and then whenever some value goes up or goes low, like the temperature is quite high, so you need to probably intervene. So those kind of things are done at this L4 level. Now, actually above L4 level, there is also an L5 level. Now, this L5 level is the ERP level. Now, what is this ERP level? This ERP level is like the overall resource planning. Like suppose you are working on a drug manufacturing unit where you are producing some medicines. So you have a monthly schedule of producing this many number of tablets and this many number of syrups. So that you plan beforehand, and that you treat with the HMI, or you feed the data to the HMI. So it's not that a machine can operate continuously. So you have to think that, okay, I have to probably produce this many number of tablets, so I need to do it within 20 days, because rest of the days probably we need some maintenance and other kind of scheduling. So the machine should run probably for 5 consecutive days, then one day it will be the cleaning and other kind of supervision should take place. So that kind of planning is done at this L5 level. And obviously all other kind of things like the record, the billing, the ordering of raw materials, and then the quality control, like because the things that are coming out of a manufacturing process, how they're working, the stock monitoring, the logistics, how these things will be going to and fro. So if you are in a medicine manufacturing plant, so obviously your raw materials are like those powders and different kind of antibiotics which is coming in, and then going out are the sample bottles. So you have to keep track of all these things. So this L5 or ERP level is not much of communication, but it is much of record keeping or database kind of thing. But they are inherently integrated to the whole system. So with this, we give you a glimpse of how an industrial control network works. Well, in an industrial control network, the hierarchies are different, the tools are different, the devices that you see are different, and they have different data transfer requirements as well. Next, we are going to talk about some thing about the IO networks. Well, I'm going to talk about these low layers. Like I was showing you this L2 level, that is the IO level. So I will be going to talk about more about this IO level, and then I will talk a little bit about this L1 level as well. So here we are going to talk about this IO level, like how this IO level works. Well, if you remember, or rather I will show you right here, that this IO level is between L1 level and L3 level. What is L1? L1 are the actual sensors or actuators or the field devices which we need to control. On the other hand, L3 is the devices like programmable logic controller, which are electronic devices which generate control signals. So the IO layer, which is in between, takes the control signals from the PLC to the field devices, and the sensed signal from the field devices to the PLC. So there is a to and fro communication that is realized with this IO kind of layer. So let us have a look at this IO bus networks. Now, when we consider bus is basically a collection of wires which transmit data or power. Well, in most of the industrial networks, still we have wired communication. Wireless communication is being proposed and is getting replaced, but you have to remember that wired communication is always more reliable, and industry people are probably still fearful about the reliability of the wireless situations. But certain moving kind of parts and like where mobility is involved, there is no other way but to use wireless. Anyway, so majority of the bus networks are still like wired, and this IO bus network allows the PLCs to communicate with the field devices, and also it supplies the power. That's also an interesting thing. So how this whole thing works? Well, at the L1 layer, we can see the control valves, the motor starters, the photoelectric switches, the push buttons. These kind of things are at the lowest level, and this PLC is an electronic device which is on the L3 level. So in between there is this two. First, there is a local area network or LAN kind of thing, which is controlling all these things, and this control network is connected to a bus network which is directly connected to this. So this is how this whole thing goes on. So the PLC is communicating through the local area network as well as the IO bus network. It directly controls these things with the IO bus network, whereas these PLCs communicate among themselves through this local area network. Now, these IO bus networks have evolved a lot. Well, earlier we had something like device bus networks, where we connected the low-level devices like push buttons or limit switches, and we only could transmit the on-off state or the status, like whether it is operating fine or not, and they transmit a few bits, like whether it is on and off or something like that. But the process bus networks, like they are high-level devices, like they connect with smart valves or flow meters, like they know if there is an event what to do themselves, and they control a whole process. They does not control only a single motor or so. They probably control the whole flow cycle, and they can transmit several hundred bytes of data. So that's why they're different. An example is shown below with a small font size. That is, suppose a process bus network, a compatible pressure transmitter can provide controller with much more information than just pressure. It also transmits information about temperature, flow rate, and so on. So it's like what I tried to convey with this slide is that earlier we had something like a very primitive kind of IO bus networks, where we consider the devices that they are controlled are primitive as well. So they can only transmit like, I am okay, I am not okay, or this is on, this is off, this kind of basic kind of data transmission. So that's what was the device bus network all about. But nowadays we have process bus networks, and these process bus networks are like they are having a lot of data, and sometimes they can probably control themselves. And the device bus networks, like what we had earlier, is like CDPlex or ASI or something, and then the device net or CAN bus. The CAN bus is still used in most of the automobile industry. On the other hand, the process bus networks has been getting implemented in large-scale manufacturing, like a steel plant, a biochemical plant, a biotechnology manufacturing unit, and so on. And they have the two major standards coming up. One is Profibus and one is Fieldbus. Fieldbus is probably more popular, and they are currently used worldwide. I will talk a bit more about this evolution. Like you can see that this is where the field bus was introduced in 1985 or something like that. And then there were other standards as well. But apart from this IO bus networks, let us now talk a bit about the device controller communication as well. Like we're talking about the IO bus networks, but let us now talk about when the data is moving through a IO bus network, how it is going to actually control the devices. Well, you can see that these things are more probably related to your departmental domain than mine. So obviously, probably you can understand better than me. But let me just tell you how the whole thing goes. Well, I'm talking about control. And suppose I'm talking about a flow control kind of thing. Like there is a flow, and this flow can be relevant to a chemical engineering plant, it can be relevant to a mechanical thing, it can be relevant to the civil engineering department. So we have something like a control valve, and then we have some kind of flow transmitter. So we are measuring the value of the flow through the flow transmitter, and then we can probably control the thing with the control valve. And there is a controller in between. So the whole system is like, you measure how much thing is flowing, and if you need, probably you can control. Now, in the earlier days, we had something like pneumatic control, like in 50s or so. They worked with pneumatic pressure. And if you consider digital kind of approach, like whether you have a 1 or a 0, then the 0 was denoted with the 3 psi value of pneumatic pressure, and 15 psi pressure denoted 1. Then it was like an electronic era, and like we had an analog era, and we had the digital era in 70s and 80s, where these pneumatic pressures were replaced with electrical signals. And in electrical signals, we transmit current. And what we had was like something called fast 10 to 50 milliampere, and then later, which is much more popular, is 4 to 20 milliampere. This 4 to 20 milliampere loop, control loop, is very, very still popular in industry. It means that when you have a current of 4 milliampere, you denote it as a 0. And when you have a 20 milliampere current, you denote it as a 1. And there is a PID controller who actually controls with this. Now, these were the earlier days, but now we are moving towards the serial digital bus. we had this RS-232 kind of bus, then GPIB, then USB, and then we had field bus in 2000. Like they have this Modbus, CAN, Profibus, and HART, and other kind of communication systems. Now this was something like the links from which we got something like the evolution. Well, so and it also shows the use of this 4 to 20 milliampere current loop, which were showing the logics of zeros and ones. So this is how this whole thing evolved, and it is still evolving. And I'm not very much aware of the exact process control, industrial control networks right now being applicable to different industries. So when you join an industry, probably you will have a better look. But I just wanted to give you some terms which might be relevant for understanding this industrial control networks. Like we had this earlier, this pneumatic control, then we had this analog control, then we had this digital control. And nowadays we are going to have this Profibus and field bus and so on. So in summary, let me review what we, actually this is the last slide of today's class. So let me just summarize what we have discussed so far. Well, we have tried to give you a glimpse of industrial control networks. The majority of our discussion was to make you understand that industrial control networks have a different type of demand of data communication. The data is generally short, but they need to be transferred really very quickly. And the reliability is a big issue. The data, although the data size is short, we don't have big data requirements. Then the second thing is the type of devices for communication is rather different in industrial control networks. We have something called PLCs, like programmable logic controllers, and the data generation things are not computers. They are generally the field devices like sensors or actuators. And mostly it is used for controlling such field devices, like how to stop a valve, how to start the temperature sensor, how to start a motor, and so on. And in this control network, we have several layers. The lowest layer is the device layer. The top on that is the I/O layer that takes the information to and fro to a controller. The controller is the PLCs, which forms the layer 3. On top of that, we have some human-machine interface layer, and on top of that, we have some management or planning or record-keeping kind of layer. The technologies that we are seeing for last 70-80 years is something like, we had something like pneumatic control earlier, then we had electrical control, and now we have much more process control buses like field bus or HART or Profibus, this kind of things that we are seeing right now. So here we end today's class. I will stop sharing. Okay. So, and I will stop the recording as well.